Okay. Hi, Trevor. We missed you in class. We wish that you could be here. On Monday when you were here, we talked about your midterms, and then on Tuesday we talked about all of our triangle congruence theorems. Okay, so the ones that we talked about before, so side, 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 angle, side, angle, and angle, angle, side. So this is all a review that we have here for the first part. And we just talked about how this one, it's going to be all the sides. Side, angle, side, it's two sides. And the included angle. This one, we have two angles and the included side. And here we have two angles and a non-included side. Okay, and it really has to do with...
You recording yourself?
Okay, it really has to do with the letters that you have and what they're next to. So side, 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 pretty easy. You got all the sides here. Okay, side, angle, side. We're talking about a triangle that's going to have a side here, and it's that angle that it creates. So this becomes the included angle. This angle right here is that included one. It's made by the two sides that you have. For angle, side, angle, you have two angles, and they're going to be congruent to two angles in another triangle, and it's the included side, so it's touching both of them. See how this S is touching both of these A's? The same thing, this side here is touching both of these angles. And the last one, angle, angle, side, we have angle, angle, and then the non-included side. So this A is only touching the S, so the S is only touching one of the A's, and therefore it's only going to be touching one of the angles here as well. So we did a review of that, which led us to do some more proofs. So we looked at this example here, that if this is a right angle, so it gives us XVW, this angle right here is a right angle, and also that these two top angles are congruent. Can we prove that the two triangles are going to be congruent? Okay. Since we have this right angle, we're going to know right away that angle XVU is a right angle as well. Okay, and that's just by definition here of them being, first you can see them being a linear pair, and then that you're going to have definition of right angles. We're going to be able to prove those two congruent, those two angles. The second thing you want to be able to pick out is that the two triangles, they share this side. So XV is going to be congruent to itself by the reflexive property. So as we're filling in our proof here, you have your angles, which were given to you. You also have that this is a right angle, which was given to you. It tells you that these two angles are supplementary, which we talked about here with our linear pair. So these angles, the two right angles, that's what these ones are. These are the two right angles that they're talking about, are going to be supplementary. Definition of a linear pair. They're going to be congruent because all right angles are congruent to one another. And remember that you need three things. So we need three things. So we have these two, the first two angles that were given to us as congruent. We have another set of angles, so this should be a 2. Another set of angles that are congruent. We need a third thing, which in this case is going to be those two side, or the side that's the same, XV and XV. And this is by the reflexive property. So if you look at your picture, and if I were to take out just one of those triangles, I have this angle here. I look at just XVW. On this side, I can see I have an angle, a side, and then an angle, which means that I'm going to be using ASA for this one. Okay, so there's some work for you to do for that one. We also talked about two other congruence things that we need. The first one was hypotenuse leg, okay, and this is for your notebook. So if you have your notebook at home or a piece of paper, this is what you want to be putting in here, okay, is hypotenuse leg. Now, your hypotenuse is always on a right triangle. So here you'd have your hypotenuse, you'd have a leg, and a leg. Okay, it's always across from your right angle here. So this has to do with right triangles only. And it says if the hypotenuse and one leg of a right triangle, and this is the important part, it's got to be a right triangle, is congruent to the hypotenuse and one leg of another right triangle, then the triangles are congruent to one another. Okay, and if we had two right triangles, just like we're talking about here, well, that's a terrible drawing, but we have these, and I'll use maybe your kind of view, TRE, here. Oh, your name is perfect. Except I want to go in the right way. So B. B-O-R. Use your name here. So these two triangles here, we say these are congruent. Flip it. These two, I think. Here I've got two right triangles, and then I have the hypotenuse and the legs congruent. So I'd have triangle TRE congruent to triangle. I don't know if I did it correctly. I think it's going to be BRAV here. Triangle BRAV by hypotenuse leg. And this is how mathematicians get away with using the AS congruence. Because they have an angle here, A, then they have a side, and they have a side. So really hypotenuse leg is really that triangle congruence theorem, ASS, that we said couldn't work for right triangles. So for right triangles, it's going to work. For other triangles, it's not going to work. So hypotenuse leg was the other one that we talked about to add on to our list. So now we have hypotenuse leg, side, 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 side angle, side angle, and angle, angle, side as our now 5. Okay. The other thing that we discussed in class was this thing called CPCTC, which is congruent parts of congruent triangles are congruent. And it's a nice acronym for us. What it's saying is that once we prove them congruent by these things, we can say the other parts are congruent. So what we would have in the one above is we'd be able to say that the two triangles were congruent, and then we'd be able to say that angle E is congruent to angle V because of CPCTC. So once we have the two triangles congruent, all the rest of their parts will be congruent because of CPCTC. And we just looked at even more proofs as well. So we looked at this proof here. We have the two angles, angle PNQ, which is here, and angle LMN, which is here. PN and LN are congruent, and then N is the midpoint. So because this is the midpoint, it's going to bisect the segment, which gives us these two congruent as well. QN is all going to be congruent to NM. And I can already see, just by being able to say that, which will be the definition of midpoint, that I have a side, an angle, and a side. Side, angle, and a side. So side, angle, side is what I'm going to want to use. And then it's asking about, are these two going to be congruent? And this is where I'm going to have CPC, TC come into play for me. So starting off with the proof, we have N is the midpoint of QM. This is where we're going to have QN congruent to NM because of the definition of the midpoint. This is the first thing. Remember, I need three things to prove a triangle congruent. This is the first thing. And then I was given that these two angles were congruent. I'm also given that these two side lengths are congruent, so this becomes given as well. And now I just want to state my triangles being congruent. PNQ congruent to LNM, and this was by side, angle, side, and then CPCTC to end off to have the other two side lengths congruent. Okay, so the proofs are getting a little smaller and hopefully a little easier for us to deal with. We also looked at this one just to get another one, and if you're all set and you know what you're doing, go ahead and do the assignment that I sent you. Here, this is just an extra one in case you want a different view as well. In this one, we have PQ and RQ congruent, and we have these top two angles. We have two things already. One, two, we just need a third thing, and in this case, it's going to be this shared side. QS is going to be congruent to itself by the reflexive, and then I can see that my triangle here is going to be side, angle, side again. And then to prove the two angles that you have here, it wants to know, are these two going to be congruent? And we should be able to say CPCTC for this. So the top two angles, this was given to us here by the reflexive property. I have the two sides congruent, QS and QS, and then I just want to state the triangles. Make sure your triangles are in the correct order. So if I use PQS, I want to make sure that I say RQS as the second one, and then CPCTC as the reason that the two angles are going to be congruent. Okay, so let me know if you have any questions or anything on these, and we hope to see you soon.